This video is going to go over the 6A review. First question asked me to find the average rate of change between x equals 2 and x equals 5. I plug it in to find my y, so I get 1 divided by 2 times, plug my 2 in, squared, minus 2 times 2 plus 3, 1. Now I plug in my 5, 1 divided by 2 times 5 squared, minus 2 times 5, plus 3 is 5.5. Then I do y minus y over x minus x, which would be 1 minus 5.5 over 2 minus 5. That gives me a negative 4.5 divided by negative 3. Negatives cross out. You can leave it like this, or you may write it as 4.5 divided by 3 equals 1.5. Both answers would be correct. You may pick which one you prefer. On example 2, I'm using the same x values, but my y values will be different when I plug it in. So I have 2 squared plus 6 times 2 plus 11 equals 27. Then I go through and plug in 5 squared plus 6 times 5 plus 11 is 66. Y minus y over x minus x. 27 minus 66 is negative 39 over negative 3, which would be equal to 13. For my average rate of change. Example 3, x equals negative 2, x equals 0. I need to find what my y's will be when I plug them in. So I enter in negative parenthesis negative 2 plus 4 squared plus 1. Then I plug in a 0 plus 1 negative 15. Y minus y over x minus x. 2 negatives will become a plus. 15 will become, that's 12 over negative 2, which would equal negative 6. Example 4. I have x equals negative 2, x equals 0 from the statement above. I find my y's by substituting those in. Parenthesis, negative 2 plus 2 squared plus 2 equals 2. 0 plus 2 squared plus 2 is 6. Y minus y over x minus x. That'd be a negative 4 on top over a negative 2, which equals 2 when you reduce it. Average rate of change where x is 1 and x is a 4. That means my y would be 1, 3, 4, 12, y minus y over x minus x, 12, 11, 10, 9, over negative 3 is equal to positive 3. On example 6, I use those same x values. Then I have y equals 1, y equals 8, y minus y over x minus x, negative 7 over negative 3, which is just 7 over 3, or you can write it as a decimal. 7 over 3 is 2.3. You may pick which way you want to write it. I prefer the fraction, it's less work. On example 7, I'm going to get h alone. So I'm going to rewrite it. H is attached to this piece and this piece. To get rid of the fraction, I do 2 over 1. I don't really need the 1. To move this piece away from h, I need to undo it by dividing. And then the h would now be alone for your final answer. Example 2 wants b1 alone. So I'm going to get rid of the fraction. I'm going to divide by the h to get it to move away from that b. 2a over h is equal to b1 plus b2. Subtract it away from the b1. My final answer is 2a over h minus that b2 equals b1. On 8, it wants me to solve the equation for y first. I'm going to try and get it alone, so I minus 6x. Divide by 3. There are going to be a few ways this is acceptable to solve for y. 12 divided by 3 is 4. 6 divided by 3 is 2x. And if you wrote it in the other order, it'd be a negative 2x plus 4. So these are all different answers that you could get and be correct. The other one for this one is if you had them switched, it'd be negative 6x plus 12 over 3. That would also be a correct statement. On the second part where they solve for x, I want to get x alone, so I'm going to minus the 3y. Divide by 6. Here's one option. The other option is if you had written the negative 3y plus 12 over 6. That would be correct. And if you reduced, this one reduced would be 2 minus 1/2 y. And this one reduced, would be negative 1/2 y plus 2. So those are the 4 different ways you could have written your equation solving for x. Example 9, solve for y. Get y alone, minus 2x. Divide by negative 3. Or it could be y equals negative 2x plus 19 divided by negative 3. If you get a different answer and you want to check it, just come ask me and I'll let you know if it's correct. Solve it for x. Add the 3y. Divide by 2. Or it could be 3y plus 19 over 2. Ten. X alone minus the y squared. Square root it. Plus or minus the square root of 25 minus y squared. Solve it for y. That just means I have to move the x first. And then square root to get rid of that power. And that's your final answer. Identify the standard form and vertex form of the following functions. Standard, I distribute it. Combine like terms. The vertex form would be negative b over 2a. Plug the 3 in. So I would get y equals a x minus h squared plus k. A is a 1, h is a 3, k is negative 4. There's vertex. Standard form on 12. Distribute that negative 2 in. Distribute. There's standard form. Then I have A, B, C. Plug in the 2. So I get y equals a x minus h squared plus k. A is a negative 2, h is a 2, k is a 2. For vertex form. 13, I need to factor it. 2 times 4 is 8, add them up to 6. Then I do vertex form, which is negative b over 2a. Plug it in. Y equals a x plus 3 squared because it changes signs to negatives, and then minus 1 is on the outside. 14, I factor out that negative. Add them up to get plus 8. Then I do Alright, we have 8 over negative 2 equals negative 4. I plug that negative 4 in. So I would have negative parenthesis negative 4 squared minus 8 times negative 4 minus 15 is negative 27. Oh, I missed an 8. Negative minus 4 squared minus 8 times negative 4 minus 15 is a 1. There we go. So y equals a x minus h squared plus k. My a is a negative 1. My first number is negative 4, and then I have a positive 1. Two negatives make a plus 4 squared plus 1 for vertex form. On example 15, I want to find standard form first. I would have 2 times x minus 3 times x minus 3 minus 2. I'm going to distribute that 2 in just to the first set. And then I distribute and get 2x squared minus 6x minus 6x plus 18 minus 2. Combine like terms, negative 12x plus 16. That's standard. Then when I factor it, I take out the 2 and get x squared minus 6x plus 8. X multiples of 8 are 2 times 4. To get a negative 6, they would both need to be negatives. That's the factors. Number 16, I write it twice because it's being squared. Distribute the negative into the first set. Distribute again. That gives me negative x squared plus 2x's plus 3. I take out the negative to factor it, which changes all of my signs. X times x is x squared, 3 times 1 is 3. To add up to negative 2, I need a negative and a positive. Transformations. Given the parent function, which is this one, identify the translation of the given function. So my vertex would be 3, 2, and it would open up, which means it went right 3, up 2 as my transformation. On this one, it would be positive 2, negative 3. It would open up as well because it's positive. So I would say right 2, down 3.
Non-traditional Christmas.
On 19, my vertex would be 3, positive 3. And it still opens up because it's positive in front. Right 3, up 3. This one would be 1, 4. Still opens up because it's positive. Right 1, up 4. Create an equation for the vertex form. I look at the vertex, it's left 3, then down 4, and it's still opening up, so A is going to be a positive 1, because it goes up 1, 3, 5, it follows the same pattern. When I plug this in, it becomes a plus 3, and on the outside it stays the same. I'm just going to write it down here. Y equals 1x plus 3 squared minus 4. On this one I have positive 2, positive 3, and it goes up 1, up, goes by that same pattern of positive 1. X, I plug that 2 in and it becomes a negative. I change its sign. The second number stays the same. Now we're in the transformations. I have k times f of x. That means that it will be a vertical. And a 3 would make it stretch. What is the transformation? Vertical, stretch. And if you don't know it, you can skip it and come back after the graph. What is the new equation? Well, if I multiply everything by 3, I would get a 3x squared minus 6x plus 6 for my new equation. And I need to graph it, so I would make a table. I'm going to plug in a 0, a 1, a 2, 3. Let's see what happens when I do that. So I plug it in to my new equation. 3 times 0 squared minus 6 times 0 plus 6. Then I want to scroll through and plug in a 1. Scroll through and plug in a 2. Scroll through and plug in a 3. So that starts to go off my graph. I have 0 up 6, 1 up 3, 2 up 6. And that would be my vertical stretch. Next one, I'm timesing it by y, so I know it's vertical. The fraction will make it shrink. What is the new equation? I have to multiply everything by 1/2. Half of 4 is 2. Half of 7, I'm just going to write a decimal, 3.5. Now I need to graph it, so I make a table. I'm going to plug in the same numbers that were on here, so -4, -3, -2, -1, 0. So I'm plugging in the points that match up with my graph that I already have. When I plug those in, I'm going to create my table. When I plug in a -4, I get 3.5, 2, 1.5, 2, 3.5. I graph those points. -4 is up 1, 2, 3.5. -3 is up 2, 1.5. Then I mirror it. And there's your vertical shrink. 25. I have my graph right here. That's my original. If I have y being multiplied by a -1, that is going to be a reflection. And let's graph it to see which axis it flips over. So if I multiply everything by a negative, that becomes a positive, positive, positive. Then I make my table. I'm going to plug in a -5, -4, and a -3. So I have x squared plus 8x plus 15. I plug numbers in. -5 is 0. -4 is -1, 0. So now my graph is opening up. It reflected over this axis, which is the x axis. (26). I am plugging a 2 in, so it'll be f times 2 of x. That is going to be a horizontal, and it does the opposite. So 2 would make it shrink. My new equation would be 2x squared minus 8 with a 2x plus 17. That would become 4x squared minus 16x plus 17. That's my new equation. I create a table. I'm going to plug in a 2, 3, 4, 5, and 6 just to see what happens. So I plug it into the 4x squared minus 16x plus 17. Okay, 4x squared minus 16x plus 17. When I make my table, I get 2 is a 1, 3 is 5, 4 is 17, 5 is 37. Oh. So it's just going to go up. Let's try plugging in more numbers. So my table needs different numbers. So that way just continue to get bigger. So I'm going to plug in a 1. I get 5. I plug in 0. There we go. Now it's starting to go up this way. 0, 17 doesn't fit. 1 up 5. 2 up 1. 3 is up 5, and then 4 is up 17. So that one, we took our graph and it did a horizontal shrink. It squished our graph together. 27, I have 1/3 being plugged in. That will be a horizontal. Then it does the opposite, so it will stretch it. My new equation will be 1/3 x squared plus 8 times 1/3 x plus 14. That would become 1/9 x squared, or you could use a decimal, plus, I'm going to use a decimal on this one, and do 8 times 1/3. I'm just going to write it as a fraction, plus 14. I would make my table and plug in, I'm going to try -6, 5, 4, 3, 2, 1, 0. Just see what happens when I plug those in. So I have 1 divided by 9 times x squared plus 8 divided by 3x plus 14. When I plug in those values, so I'm going to make a table for 27. As I go through and make my table and plug numbers in, -6 is a 2, -5 is a decimal, 4 is a decimal, 3 would be 7, and then 0 would be 14. So based off that pattern with the decimals, I'm going to make a new. So it's going by threes. So I'm going to try -6, 7, 8, 9. It's -1. -12 is -2. -15 is -1 again. So there it went back and made our U shape. So 0 is up 14, won't fit. -3 up 7 won't fit. So when I try and graph it, it won't fit on the graph. So that's where this piece is going to be really nice to know, so that you can still get the points for this, or you can graph it on a separate piece of paper if you want to. (28), I'm plugging a -1 in by the x. This will cause a reflection, and let's see what it reflects over. So if I change just the inside to a -x, a negative squared will become a positive. That will be a -8x plus 17. I make a table to graph it. I'm going to plug in x squared minus 8x plus 17. And when I go through and make a table, I would plug in, let's see, 2 is a 5, 3 is 2, 4 is 1, 5 is a 2, 6 is a 5. There's my parabola. Notice that all of those points would be over here. It would be 2 up 5, 3 up 2. It would be over here, which means that it reflected over the y-axis. honors section, you don't have to do this part. It's really hard, but I'm going to do the examples in case you want to try and get the extra credit on the test. First, you'll draw a picture. So a suspension bridge has two supporting towers with a cable secured at either end of the span, then drop off the tower. In the section between the two supporting towers, the cable forms a parabolic curve. At the lowest point, the curve is 12 feet. From the surface, the supporting towers are 300 feet apart and rise 320 feet from the surface of the bridge. Use the height of the left tower as your y-intercept. So this one will be my y-intercept. This would be my vertex. The vertex would be over half the distance. So that would be 150, would be half the 300, and then up 12 for the vertex. Y-intercept would be 0, up 320 feet. What is the equation of the vertex form? Y equals ax minus h squared plus k. I know that my vertex, when I plug it in, would be x minus 150 plus the k is 12. But I don't know what a is. This is where the honors section kicks in. I have to plug in x and y from my y-intercept. So I would get 320 equals a, 0 minus 150 squared plus 12 minus 12. That gives you 308. Divide by and a is equal to, I'm just going to enter that in, 308 divided by 0 minus 150 squared. And then to get it from decimal to fraction, you do second, and then yours will be like, yours calculator will be different. It's second, and then it has an F to D arrow. It'll look like that, fraction to decimal arrow, which is 7 over 6, 2, 5. Let me double check and make sure that the way I typed it in is correct. Yep, alright, so that is my A. For my final answer, I would have y equals 77 over, and then I copy x minus 150 squared plus 12 for my formula that represents the quadratic for the bridge. On the next question for the amusement park, this is honors as well. I first am going to draw the park. So an amusement park is a building roller coaster with drop section modeled by a parabola. The roller coaster will dip 8 feet below the ground. So roller coaster drops below the ground, goes back up. Okay. Goes 8 feet below. That's a -8. The roller coaster will dip below ground level at a horizontal distance of 24 feet. And then it will reemerge at ground level at 54 feet. This would be the y-intercept. and this will be the vertex. What is the equation of the parabola that models the drop from the peak to the emergence at the ground level? Well, I'm going to use factor form. So y equals a, x minus p, x minus q. These are the intercepts, so I'm going to plug those in. X minus 24, x minus 54. Then I need to find a, so I'm going to use the vertex for that. My vertex would be the middle, so 24 plus 54 divided by 2 is 39, comma, down 8. I plug these in for my x and my y. And then to get a alone, I would have to divide by whatever this total is. I'm just going to enter it in to calculate it. 39 minus 24 times 39 minus 54 is that would cancel those out. Negatives would become positives. So my final equation, I would write 8 over 225 for my final equation. What is the height of the peak just before the drop? So it wants to know what the y-intercept is before it drops down. To find that height, I take my equation, and that height would be at 0, so I'm going to plug in a 0 for x. 8 divided by 225, parenthesis, 0 minus 24 times 0 minus 54 is 46.08 for the height. And that's how you do the honors questions.